All right, guys and girls. So the 15th, August 15th lesson was about multiplying integers. That was our objective. So again, with the notebook, I do want you to label the pages at the top. That way it's easier for my student aid to grade. And I do want you to date when we start a new day of notes each day. So 8/15/2018. So our lesson from last class, or from the 15th. First question I had here was a times table multiplication. So I was asking you to do, for example, 8 by 5. So when you're looking at 8 by 5, or 8 times 5, what you should be thinking about is 5 groups of 8, or 8 groups of 5. So if I add 5 groups of 8, in other words, 8 to itself 5 times, I have 8 plus another 8 is 16. That's 2 8. That'd be 8 times 2. Plus another 8 is 24. Plus another 8 is 32. Plus another 8 is 40. So again, this is 5 groups of 8. 8 plus itself 5 times, which is 40. You should be getting to the point in your mathematics understanding where you have memorized most of these facts, these single-digit multiplication facts. However, if you have not yet, you need to relate multiplication to addition. I do film these during school, so you'll have to deal with the bails here now and then. Second question, 9 by 6. So again, we want 6 9s added together. Or we can think of it as 5 9s plus another 9. Most of you are very familiar with your 5s. So most of you would know that 5 9s is 45. There's 5 9s. I need to add one more 9 to that. 45 plus 9 is 54. I believe that the most important multiplication facts are the 5s and the 10s. You need to be able to do 5s and 10s very quickly and efficiently. And then you can add in the extras afterwards. So for example, here I did 9 by 6. I took 5 9s and added another 9 to that. If it was, for example, 9 by 7, I would take 5 9s and add 2 more 9s, which would be 63. Or if it was 9 by 8, I would take 5 9s and add 3 more 9s. Or I could take 10 9s and subtract 2 9s from that. As you get older, multiplication should start to be more efficient for you, easier to do. So this should start to make better sense as you get older. I know some of you have struggled a lot in the past with this concept. I did grade your practice test. Some of you struggled very much with this. All right, so 4 7s or 7 4s, here's what I have here. So I have two options here. I can take 5 7s and subtract 1 of those 7s, or I can add 4 7s together. So if I want to, I can take 7 by 5, which is 35, and subtract 1 7 from that, which is 28. 35 minus 7 is 28. Or I can do 4 7s added together. 7 plus 7 is 14, plus another 7 is 21, plus another 7 is 28. Again, you need to be able to relate multiplication with addition or subtraction, depending on if you want to go above the multiplied product or below it. And it should make sense to you why this could be 7 times 5 minus 7 times 1. 5 7 minus 1 7. This should make sense to you, how this is functioning. 35 minus 7 is 28. Or again, we could do 7 plus itself 4 times. 7 plus 7 is 14, plus another 7 is 21, plus another 7 is 28. All right, next one here, 6 by 8. So here, again, we can do 6 by 5, or we can do 6 by 5 and then add another 3 6s to that. Or we can do 6 by 10 and subtract 2 6s from that. So 6 by 5, which is 30, plus another 3 6s, which is 18. 6 by 5, 30, plus 3 more, 18, is 48. 6 by 8 is 48. I would prefer highly that if you could, you would memorize the entire multiplication tables, 1 through 12s. However, I do understand that some of you are going to struggle with that and have struggled with that in the past. I want to present something that all of you should be able to do. That's why I'm doing the math the way I'm doing it here. All right, question 5, double-digit multiplication. So 12 by 5. So again, this should be something that you should know, 12 by 5. However, if it does confuse you, 12 by 5, perhaps you might want to break it up into 2 separate multiplications. For example, 10 by 5. So there's 10 5s plus 2 more 5s. And the reason you might want to break it up this way is because 12 5s is the same as 10 5s plus 2 5s. I do like to use 5s, so I really wouldn't want to break up the 5s into something else like 3s and 2s. But the 12, maybe I'm struggling with my 12s. So I break the 12 down into a 10 and a 2. 5 10s, which is 50, plus another 10, 60. Next one, 11 by 8. So again, perhaps I'm struggling with my 11s. So perhaps I would do, instead of 11 by 8, I would do 10 by 8. So there's 10 of my 8s, plus one more 8. 80 plus 8, which is 88. Next one, 9 by 13. So 13 is not on my times charts. So I would most definitely break this up into 2 separate multiplications. And I would say 9 by 10 and 9 by 3. So here I've got 10 of my 9s. I'm going to add 3 more of my 9s to that. Notice here how multiplication is commutative. I don't have to break up the first number every time. So here I broke up the 11 into 10 and 1. I can break up the second number instead if I want to. I broke up the 13 into 10 and 3. I can break up either number. I broke up the 12 into 10 and 2. Or I broke up the 6 into 5 and 1. Or I broke up the 7 or the 4 into 5 minus 1. Or I broke up the 8 into 5 and 3. So it is optional which number you want to break apart. Again, I recommend highly use 10s and 5s when you're breaking the numbers apart, as it makes things much easier to memorize, as 10s and 5s tend to be very easy to memorize. So 90 plus 27 is 117. All right, next one. 23 by 11. So this is 23. Well, I would use a 10 here.
Rin Covington, if you're on campus, please come to the front office. Rin Covington, come to the front office. Thank you.
So there's 10 of my 23s plus another 23. Now, why would I use 10s? Well, again, because when you multiply by 10, it just adds a 0 to the end of the number. It moves the decimal over one place. So this is 23 right now. When I multiply it by 10, it will be 230. So now all I have to do is take 230 and add 23 to that. 230 plus 23 is 253, which is perhaps easier than doing the original multiplication. I don't care if you set these up vertically. Some of you have been taught the vertical setups, and that is very efficient. That is the way I learned in high school as well, and actually in middle school and grade school. So if you would prefer the vertical setup, that's fine. And that is very efficient, very effective. So the vertical setup again here for this question, if I was to use the vertical setup, would look like 23, put this times sign as an x, 11, and I would have 3 times 1 is 3, 2 times 1 is 2. Then I'm in the 10 spot, so I have a 0 here to represent tens because I'm doing 10 times the number. So 10 times 3 is 30. So this is why it's a 3 here. And then 10 times 20 is 200. So that's why that's a 230 there, because I did 10 times 23. Anyway, so I get 253 when I add this down. That's a plus sign on the far left, 253. If you prefer the vertical setup, that's fine. I know some of your parents, that's what they taught you, and maybe some of your teachers, perhaps that's what they taught you as well. I am trying to present the setup that most of you learned in grade school so that I can continue on with what your previous knowledge is. But you are welcome to use any setup that you desire. All right, 24 by 13. Again, I would break this up into tens. So I would say this is 24 times 10. And I put 240 there because that's what 24 times 10 is. 240. So there's 10 of my 24s, and then I have 3 more to add to that. 24 times 3. So this here now I can break up again if I want into smaller numbers from the 24. For example, 20 times 3 plus 4 times 3. Or I could do 10 times 3 plus another 10 times 3 plus 4 times 3. That is 72, though, 24 by 3. And again, the way I did that, perhaps I did 20 times 3, 60 plus 4 times 3, 12. Anyway, so 240 plus 72, which is 312. I am going somewhat quickly through these. You do not have to be quick with the multiplication in this class. You do have to be able to do it properly, though. It is something I am going to require. All right, one more of this type, and I'm going to move on with integers. 18 by 15. So I would use 18 by 10 first, because again, groups of 10 work out nicely. And then 18 by 5. So notice here that 5 is half of 10. So when I do 18 by 10, I get 180. Because 5 is half of 10, 18 by 5 is half of 180. Or in other words, it's 90. 180 plus 90 is 270. As I said before, you will get quicker with this as you age in high school. And eventually it will start to make much better sense to you as a student. All right, our other concepts today. Next thing I want to present to you is what happens when you multiply a negative times a positive. So here are 3 examples of that. So what is a negative 6 multiplied by a positive 2? Now this is a multiplication. It's got parentheses around both items, so multiplication is implied. It's not directly written, but it's implied. Next example. What is an 8 timesing by a negative 5? And the third example here I want to present for you is, what is 11 timesing by negative 8? So, what happens when we multiply a negative by a positive? This is the same as normal multiplication. However, it is a negative number that is multiplied by a positive number. So whereas normal multiplication, for example, on number 5 here, this would be like 12 people owing me $5. So I have $60. Or it would be like being paid $5 12 times. Or like having 5 or 12 $5 bills in my wallet. So I have $60 total. So this is 12 $5 bills. Or like here, this would be 8 $5 bills. $40 total. It doesn't make as much sense when we say $8 bills, but this is 11 $8 bills or 23 $11 bills. The negative numbers here represent a concept similar to debt. So if I owe $6 to 2 people, how many dollars total do I owe? Well, I owe $12 total. So this is why this answer is negative, because I owe $6 to 2 people. Or you could say I have $6 in the hole with 2 people, or I could say 2 people have a debt of $6. Something similar to that. Same concept here. This would be like owing 8 people $5. So notice I took the $5, that's the part that we owe, because it's negative here. I owe $5 to 8 people. In other words, I'm $5 in debt or indebted to 8 people, 8 different people, which is a total debt of $40. This is why this number is negative. I am in debt. I am not positive. My balance is not positive here. And here, 11 by negative 8, this is a debt of $88. This would be, again, 10 times 8, and then adding another 8, the same as it was here. So you can see here the product is still the same. It is just, however, negative when one of my numbers is negative. So the key concept here with these 3 questions was a negative times a positive is negative. And a negative times a positive is always negative. A single negative times a single positive is a negative product, because it again is like debt, owing 2 people $6, or owing $6 to 2 people. All right, next items. So here are 3 more examples. However, this time both the items are going to be negative. So for example, negative 4 by negative 5, or negative 8 by negative 7, or negative 12 by negative 5. So what does it mean when both the items are negative? We still have the product here of 20, because 4 and 5 is 20. However, is our answer negative or is it positive? What do you think? So a double negation is something that is very difficult for many students to understand. When we have a double negation, it is similar to a double negation in English. So it's similar to the concept of saying he is not tall. Now your English teachers and all your other teachers in your previous classes told you not to say something like that because it's inappropriate. And the same thing applies with mathematics. It's inappropriate to have 2 negatives in the question. So that's why 2 negatives becomes a positive. So when I say somebody is not tall, it means they are tall. He is not tall, it means he is tall. The double negation cancels itself out is what it's called, or reduces itself out. You can also think of this saying as you're $4 in debt, but to 5 people that are indebted to you. So 5 people are indebted to you $4 in debt. If that makes better sense. This is why this is positive 20. So you actually have $20 because 5 people actually owe you $4, or 4 people actually owe you $5. You could read it either way here because, again, multiplication is commutative, and only one of these numbers is negative. Same thing applies on number 15. 8 by 7, again, that's 8 by 5 plus 2 more 8s. So 8 by 5 is 40 plus 2 more 8s, which is 16. So that is 56. And then 12 by negative 5. So again, you can read that as 12 by 5 plus 2 more 5s. So 50 plus another 10 is 60. So here we have the concept of a negative times a negative is positive. When there are 2 negative signs multiplied together, or 2 negative numbers multiplied together. Anyways, so that is what we did on the 15th for our notes. For our work that I asked you to do either in class or at home, here it is. So this will be on the second page. You'll just turn the page over, label this with a 2 in the top. And there's our work. 10 questions. You can pause the video now and you can write them down. Good luck. Please, if you have a question, come in before or after school. Before school is better. I'm here much more before school than I am after school. And we can discuss anything that you had issues with. Goodbye.